What is embedded C? Is embedded C is a new language, or is it an enhanced language from the C that we are using? Or is it totally a new language definition? Let's try to understand what is this embedded C. Before going further, let's ask ourselves, which is a C that you're using? Which is a C that you're practicing? Maybe at your college you practice C. Maybe at work you have used C. What is that C? It's ANSI C. It is called as ANSI C, American National Standard Institute, as standardized the C language. We call them as ANSI C. ANSI C is what is followed by many such compilers which work on your PCs, laptops, and many other such compatible devices. Okay, then what is embedded C? In short form we call it as EC. What is embedded C? Do we need to understand an embedded C as a programming language which is used to program embedded system? Yes, that's correct. Embedded C is the C programming language used to program embedded devices. I have a mathematical equation to make you understand about embedded C in a better way. Embedded C, EC, is equal to ANSI C plus X minus Y. This is a mathematical equation which could describe embedded C. Okay, here embedded C is made out of three different objects. One is ANSI C, then plus X minus Y. If we need to be clear understanding embedded C, then we must understand what is ANSI C and what is this plus X shown in this equation, and what is this minus Y shown in this equation. Okay, we'll try to attempt understanding what is ANSI C. What is ANSI C? We know that, okay, ANSI is a standardizing institution which standardized C. Okay, further understanding about ANSI C. ANSI C is a standard C compiler designed for x86 and compatible processors based computers like your PCs, laptops. ANSI C is a standard C compiler which are designed for x86 based computers like your PCs and laptops, which can compile your source code, the C source code, to an understandable format for your x86 processors such as PCs which are based on 8086 like 8088, 80286, 80386, 80486, Pentiums, now dual cores. These are all compatible CPUs. ANSI C has defined the compiler standard for such processors. That's what is ANSI C that we are practicing and that we are using. Okay, that's ANSI C. Okay, getting some more in-depth understanding of this. I have brought in 8086 architecture just to understand the various resources which are available in this particular CPU. The resources available here are registers. Here we have some general purpose registers, and we have some special registers. We have flag register. These are registers accessible by the programmer. Then we have ALU, which could do all the operations which has been defined even in C. Fine. Now, someone who's trying to design a compiler for x86 based computers shall use these resources, the resources such as these registers shown in this architecture, some special function registers. Apart from that, yes, memory which are supported by the CPU, the various I/O devices and peripherals. These are the various resources which are available in x86 based computers. Now, the C compiler designer must have to use all these resources to convert every statement of C to assembly, further to machine code. Okay, now this is x86 architecture. I'm just going forward, taking a typical microcontroller, a basic microcontroller such as Intel 8051 controller. I have shown the block diagram of such controller here. Has got CPU. Apart from that, it has a lot of other devices on chip. There are some I/O devices which are on chip. The CPU will have registers as usual, some general purpose registers and special function registers. In fact, 8051 supports a lot of types of registers. Apart from that, this microcontroller comes with some amount of on-chip ROM, on-chip RAM, an I/O device such as timers, the serial port, UART, some I/O ports, fine. I have listed the various features of 8051 here. Has got 32-bit I/O port, has got UART, timer, bit memory which can be accessed bitwise, where you can read write a bit, and various general purpose registers and special function registers and register banks. Apart from this, there might be other devices which could be integrated in this chip, like ADC, DAC, I2C controller, CAN controller, etc. Now suppose if I need to design a compiler for 8051, then I would need to use all these resources: I/O ports, UART, timer, bit memory, SFRs, register banks, and various other peripherals which could be integrated, I/O devices which could be integrated. So, to support my I/O devices which are on the chip, like UART or timer, I think the compiler designer may have to come with a few new libraries. And since there is bit memory supported here, then I can bring in a new data type called as bit. To access SFRs apart from the general purpose registers, probably there could have been a new keywords brought into this language. To support the IO port, there could have been few libraries which could have been brought in. Yeah. I think as a compiler designer, we have to do that. Yeah, that's what is plus X. Plus X is referred as language extensions. The additional libraries to support peculiar features of the target controller. The new data types, the new facilities which is brought into this language. In addition to ANSI C, is what is language extensions. Okay. Next, minus Y. This minus Y is the limitations which is brought into this ANSI C. Limitations on memory use, limitations on stack use, few libraries, the standard libraries which are available in ANSI C not getting supported, unsupported libraries, constraints on code size, constraints on deterministic outputs. These are the limitations for embedded C compiler. So somebody who's designing this embedded C compiler may go through these limitations, and that's what is minus Y. Try to understand. Embedded C is equal to ANSI C, which means it's almost similar to ANSI C. The entire C constructs are similar, but in addition to that, there is a few language extensions to support peculiar features of the target controller. And then there are some limitations in this environment. In the embedded environment, there is some limitation. That's what is embedded C. Embedded C is as equal to ANSI C with some language extensions and few limitations. I was just working out the difference between the C and embedded C. Then came to know that C and embedded C rather has many similarities than differences. The concepts are same. Most of the language definitions remain same. There are just very few differences between them that we have already discussed, like C is used for x86 desktop computers, while embedded C is used for microcontroller based applications. C takes more resources here, like memory, operating system. Embedded C has to use the limited resources which are available on the target board, the available RAM, ROM, IOs. Compilers for ANSI C typically generates OS dependent executable files. An executable files which could be started or invoked by OS. Whereas embedded C requires to compile to create files to be downloaded directly on the controller. Embedded compilers gives access to all the resources in the given system, while the C compiler, that's your ANSI C compiler, has got restrictions. Embedded systems often have the real-time constraints. Hence, the embedded compiler shall produce deterministic code, which is not the case in your desktop computing facilities. Embedded systems often have memory constraints. Hence, the embedded C compiler shall generate compact code, which is not the case in desktops. Embedded system often do not have consoles like monitor or a keyboard, which is quite often available in a desktop computers. This could differentiate, okay, the environment, the programming environment of embedded C and the desktop C. I think that's okay what I wanted to say you, okay, about embedded C. So remember this mathematical equation. EC is equal to ANSI C plus X minus Y. We know ANSI C is a compiler definition for x86 based computers. Plus X refers to language extensions, minus Y refers to limitations brought into this language. That's it. I cannot close this session by thanking you. My sincere thank you to you. Thank you very much.